we have to find the confidence interval for a population proportion. And this is, I believe this is where we stopped yesterday, which is I mentioned to you guys that we can use the calculator to calculate this proportional population proportion, right? Instead of doing all of that long formula and all of that tedious decimal, we can use the calculator. And to use the calculator, you need to press stat, scroll to test, scroll down to one prop z interval. Reminder is one prop z interval, not one prop z test or not two prop z interval. So again, it's the one prop z interval. So looking at this thing here, let's take a look at the problem we have. And I don't think we did this yesterday, which is again, if we take a look at this problem and you ask yourself, again, this is what they ask you, is A, find a point estimator, right? So, but let's take a look at the information. According to the US Census Bureau, 42% of the men who working at home were college graduate. In a sample of 500 women who work at home, 162 were college graduate. So looking at this thing here, this is the reason why I did the formula individual step for you, so that if they ask you to find the point estimate for the proportion, you know what the point estimate is, right? But before we do that, before we can do any point estimate or find a confidence interval, what do we need to construct the confidence interval or to do this item here? Well, we know that we need the N, right? We know that we need the total of people in the survey or the total of the item that we have. And then once we know the N, we need to know how many of those total are the people that fit the description that they ask us or the category that they give us, which is in this case, the category is the college graduate, which is the 162 female woman were college graduate, right? Which is now, once we have this, which is now all we need to do is we can use the stat test one prop z interval, and then you just enter in your X, enter in your N, and enter in your level of confidence, your C level, right? Which is looking at this thing here. Let me ask you, how do we find the point estimator if we don't type in here? You can type in here and you can find that answer. If you don't, to find the point estimator, reminder, all you need to do is take the X divided by the N. That is your point estimator, which is the X divided by the N. How many we have divided by the total. But if you don't, do you agree that we can use our calculator? And let me show you the calculator. Just let me start. Again, if you look at this calculator, again, let me, I use an 84, but it's the same. 84 and 83 is the same feature for this one here. So again, if you use your calculator, if you hit stat, you go over to test, and then you scroll down. Reminder is one prop z interval, not one prop z test or not two prop z. It's the one prop z interval. If you choose this option, again, they ask you for the X, which is in this case, the X is 162. They ask you for the N, which is the N in this case is 500. And they ask you for the confidence interval, which is in this case, the confidence interval is 0.98, which is 98%, which is, again, it doesn't matter which confidence interval you plug in order for you to find the point estimator. Again, if you plug it in that item, the point estimator is this item right here, ladies and gentlemen, which is P hat is equal to 0.324. So that is your point estimator. Or if you don't see that, you can just type in, again, you can just type in 162 divided by 500. And again, that is your point estimate, which is the X bar divided by the N. Okay. So again, my point estimator, as you can see, is 0.324. Okay. And the same answer, if you type in, which is that same calculation or calculator, if you look at that, it's the same in terms of the confidence interval that we have, right? So looking at this thing here, question of how to type in how to type in your data, how to use your information, or how to extract your information and use that information to find the answer here. Question of this thing here in the sense of the interval I have is 0.25275 and 0.373, which is, that is my interval. That is your calculator do for you. You don't have, like we did yesterday, you don't have to find a standard error. You don't have to find the margin of error and then, you know, take the margin of error plus the point estimator and subtract the point estimator. Your calculator can do wonder, which is your calculator can do this for you. The only thing you need to do is you need to tell your calculator that this is the information I have and I want you to use this feature to calculate it, okay? So question would how to find A and how to find B. And the question here, A or B. So if you look at the follow-up question, if you don't have question with A or B, the follow-up question is they ask you, based on the confidence interval, is it reasonable to believe that the proportion of the college graduate among the women who work at home is the same as the proportion of the college graduate among the men who work at home? Explain. So looking at this thing here, do you agree that they are not the same? Why they are not the same? Well, first of all, the ballpark, the range, the interval that we calculate is between 0.27 and 0.37, right? So it's between 27% and 37% in that ballpark, right? But the percentage from the Census Bureau, they give us 43%, which is the 43% is not within this range, is not within this interval. So we say that they are not the same. If the range contain that, we say yes, they might be the same because they can be the same because it contains the information we have. It's inside the interval that we have. But looking at this thing here, based on this sensor, 43%, that's among the men, right? Which is the 43%, if you convert it, is 0.43, which is 0.43 is not contained inside this interval. So we say that they are not the same. If they were to contain in this, then we say yes, they can be the same. Okay. So again, later on when we get to chapter 8, you will see that we have other steps, other item that we can do to come up with a conclusion. But for now, we just want, based on the range that we calculate, right? The range that we calculate, and we want to see if this range contains the item that we have, contain the specific route value that we have. So look at this thing here, we know that they are not the same, okay? Because they do not contain the percentage or the proportion of the men. So question with this example 2 here. So if you don't have question with this example 2, let's take a look at example 3. Which is, again, if you glance through this thing here, example 3 is very identical, right? Very identical in the sense that, again, they give you some sample, they give you the sample, and they give you some item in terms of the category or the condition that have to met, right? So again, an internet service provider sample 540 customers and found that 75 of them experiment an interruption in high-speed service during the previous month. So now, again, if you look at part A, part B, and part C, it's very similar to the previous one. They actually find a point estimator for the population proportion, find or construct a 90% confidence interval for this proportion. And then again, they ask you if this manager claim that is no more than 10%. Experiment, is this true, right? Can we prove, or does it contradict? So, but to do anything, right? To do anything, the two things that you need is you need an and you need an x. For a proportion, you need that. You need an and you need the x. For the mean, you need the n, you need the x bar, you need the standard deviation, right? But for this one here, we need the n and the x. And again, the other thing is you need the confidence level. But looking at this thing here, do you agree that to find a point estimator, all I need to do is take 75 divided by 540? And if you do that, or if you type in, go through this process, stat, test, one prop, z interval, they will give you the same number, which is the point estimator. The percentage, the middle percentage that we use to guesstimate my interval is 0.139. So looking at this thing here, question with how I find this point estimator, which is again, simply all I did was I take 75 divided by 540. And that will give me, again, I think it's like 0.38888888888. And I round up to be 1.39 or 0.139. The question with point estimator. And if you type it in one prop z interval, your interval should come out to be 0.114, comma 0.163, right? And I want to point out one thing before we continue is, if this is one thing to check your answer. Whenever they ask you to construct a proportion, whenever they ask you to construct a confidence interval for a proportion, your answer will always be a decimal, ladies and gentlemen, because the proportion is in percentage, and the percentage is basically the maximum percent is 100%. So if you look at example 1, example 2, and example 3, your answer is always a decimal, because that is what proportion is. A proportion is basically the percentage, right? This thing is like 13.9%. Right? This is 11.4%, 16.3%. The reason I mention that is because when you do the quiz or the test on Connect Math, make sure you have that decimal. If you don't have a decimal on the problem with the proportion, the answer will be wrong, okay? And your answer will always be between 0 and 1. That's what proportion is. It's a ratio of something, is always between 0 and 1, okay? So looking at this thing here, question on everyone, do you guys have this interval on your calculator? If you type it in, the one prop z interval, the x is 75, the n is 540, and the confidence interval is 0.90. Everyone have this interval? Or I should ask, does anyone do not have that interval? All right, I take that all of you guys know how to use your calculator. So now let's take the follow-up question, right? The follow-up question is, the company quantity control manager claimed that no more than 10%. What does it mean, no more than 10%? Do you agree that no more than 10%, meaning the maximum percentage that the customer experience this interruption is 10% and below, right? No more than meaning 10% or less, right? So again, this is what he say is, on the previous month, there's no more than 10% of the customers should experience the interruption, right? So does the confidence interval contradict his claim? Contradict this claim, right? So looking at this thing here, does it contradict? Well, do you agree that it does contradict his claim, right? His claim is no more than 10, meaning again, 10 is the maximum percentage of customer, right? Our 540 people, only 10% of that, meaning 54 of them, right? 10% of 540, meaning 54. Looking at this thing here, we can see that it's more than 54 people. But again, he claimed that no more than 10%, which is, you can see that the 10% is not within this interval, right? 10% is somewhere less than 11%. That's why this thing here, we calculate and it contradicts his claim. He claimed that the maximum percentage that could happen is 10%. But when we calculate and when we guesstimate and when we construct this 90%, we conduct this 90%, meaning again, the leftover is the 10%, right? We conduct the 90% interval, and the 90% interval is between 11 and 16, which is again, the 10% is not in there, okay? So again, looking at this thing here, everybody see that basically the follow-up question is to ask you, can you use this interval to justify the specific value? If the specific value is in that interval and we say, okay, we can live with it, it's contain that item. If it doesn't, then we say, no, this thing not working out, right? So question with this.
Wait, if that's okay.
What's that?
I have a question real quick.
Yeah.
I was doing the homework with this exact problem, right? With the part C, right? How close to 10% does it need to be? Because I had one where the confidence interval was like 0.104, and then I put that it contradicted because 0.104 is technically higher than 0.10, and I guess it said I was wrong. So does it have to be, how close to 10% does it need to be? Is my question.
You say yes, it's contradict?
Well, it was like 0.1046 or something, you know, it had like a couple extra.
And then the answer say no, it's not contradict, or is it contradict?
I put that it did contradict and it said that I was wrong. Maybe because when you round up, if it's 0.104, you don't have to round, so technically it's 0.10, I guess. I don't know. I was kind of confused by that.
One thing is, I have no clear answer to how close this should be, because again, this problem is clear that the 11% is not include the 10%. Send me that problem for me on your homework. Click on ask my instructor, so that send me that exact problem so I can know what kind of question they asked you exactly.
Well, I already retried the question and I did it again. Like it took me like 3 times and I finally got it right. So I can't really go back to the question now.
I mean, you can go to that question and click, like you can go to that homework, go to that question and view it, and then click ask my instructor. And then, you know, so that I can see the exact question and I know what they asked you. You know, because sometimes they change in one word. Because this thing here they ask you, does it contradict, which is yes, it's contradict because it doesn't contain the 10%. If they change in one word, and then that's why sometimes it's changing the question.
Oh, you know, I bet you it asked me that is it less than 10% versus no more than 10%, and I may have just read it wrong.
Yeah, so you know, that's one thing. That's why it's hard for me to answer your question, because I don't know the exact question. Like I say, you know, statistic, one word will change it. So this one here say no more than 10%, you know, so I'm not really sure if they say at least 10% or something like that nature. So in order for me to answer your question exactly, I kind of have to know the exact wording so that I can, you know, because right now if I say something and then you go back and you say, wait a minute, he say this, and then the answer is not, so it's kind of hard for me to tell you exactly how to answer the question if I don't know the exact answer or the exact question.
I just need to make sure that I read the question completely and make sure that I'm reading it right. So, exactly. Thank you.
Yeah, exactly. That's the one thing is a lot of students is they look at this thing here and they say, oh, based on, because all of the problem, as you will see, is very similar, and then they go in and the follow-up question they change in one small word, and then you have to kind of think it a little bit differently. So that's why it's a little bit critical thinking in that way too. Okay. All right. Let's try another one. Well, I don't think I have another one. Let's take a look at, if you don't have question, and again, hopefully all of you guys, since you guys did not ask me about the calculator, hopefully you guys know how to use the calculator so that you guys see how to find a point estimator, which is the p-hat, and how to find a confidence interval for this proportion. Okay, and again, like I say, the calculator help you a lot in the sense that we don't have to do all the tedious formula like one step at a time, and using all the decimal place. If you don't have question with the confidence interval, the second half of 7.3 is how do we find the sample size, right? How big does the sample size need to be for us to have the margin of error that we needed, which is again, same idea in 7.1, which is in 7.1, remember to find a sample size, the n is equal to the critical value times the standard deviation divided by the margin of error square, right? That's in 7.1. In 7.3, this is what we have, which is again, this is our margin of error formula, which is the z critical value times the square root, which is the standard error. Now we want to do the algebraic expression, try to do the opposite operation to get n by itself. So after you do your algebraic expression, this turned out to be the formula for the n. So if they ask you how large is the sample size is, or how large does the sample size have to be, basically this is the formula. Your calculator do not have the built-in formula here. This thing here, you have to type it in at is in percent of this. Okay, so again, this is basically again n, which is the total number of items, the total sample size is equal to p hat multiplied to 1 minus p hat multiplied to the z critical value divided by the margin of error square. Okay, it's only this item get the square. It's not the p hat and the 1 minus p hat get the square. It's only the second item. Okay, so this thing here just the same as in 7.1. As long as you have a decimal. As long as you have a decimal, you have to round up to the whole number. Unless your answer is exactly 117, then the answer is 117. If it's 117.05, you have to go up to 118. Okay, so again, you have to go to the next whole number. The second problem that we deal with is what happens if we don't have the point estimator? What happens if we don't have the previous p hat? Well, this thing tells you that if we don't have the p hat, then again, if you have your data, you can find the p hat. If you don't have the data, then this is what they tell you is we will assume that the p hat will be 0.5, which is 50%. So if we ask, right, if I ask how many of my students use an iPhone, and let's say we're not in class, I don't know, I would just assume that would be 50-50. So if we don't have the p hat, will be 50% use an iPhone, 50% does not use an iPhone, right? So that will give us p hat equal to 0.5, and 0.5 times 0.5 will give you 0.25. So in short, if you don't have the p hat, if you don't have a proportion, then this is what they tell you to do is we're using 0.25 multiplied to the critical value divided by the margin of error square. Okay, so again, that's the two different, which is this up here. If we have the p hat, we will use this formula. If we don't have the p hat, we will use this formula. This 0.25, just imagine this 0.25 is a fixed number. Okay, the 0.25 is a fixed number. If we don't have the p, that will be the number we use. It's basically 0.5 times 0.5. Okay, so those are your two criteria, or those are two formula. So let's take a look at the example and see what formula we have and which one that we use. Okay, how is the economic? So a poster wants to construct a 95% confidence interval for the proportion of the adult who believe that the economic condition are getting better, right? So he wants to conduct this 95% interval. He want to have this interval between what proportion does the adult believe that the economy getting better, right? So looking at this thing here, how many people should he ask? How many people should he survey, right? That's the question. So in A, they say that the Gallup poll estimate that this proportion to be 0.34, meaning based on this poll, based on the period poll, the proportion that people think that the economic is getting better is 34% or 0.34. Again, proportion will always be in decimal form unless it's in percentage form, right? So looking at this thing here, 34, using this estimate, so we have to use this item and we need to ask ourselves, what is our sample size that we need so that we have a margin of error of 0.03. So looking at this thing here, if you see this thing here, this is our formula to find n. And to find n, we need p hat, which is in this case, the poll give us that p hat. And then we need a margin of error, which is the margin of error is 0.03. The only thing that we don't have for now, which is the z alpha over 2, the z critical value, which is again, what is the z critical value? Hopefully by now, you remember that the z critical value for 95% is 1.96. But if you don't, your chart is there for you, right? Which is again, the z critical value, which is the bottom of your table A3, which is 95%, the z critical value is 1.96. So do you see that we have everything we needed to plug into this formula? My p hat 0.34, my 1 minus p hat will be 1 minus 0.34, my z critical value 1.96, my mean, not my mean, sorry, my margin of error is 0.03, and I need to square them up. So one thing is, once you fill this thing in, for me, I like to do it step by step. For me, I like to do it in this way, which is again, I like to type in 1.96 divided by 0.03. And then whatever this answer is, I just tell my calculator, take this answer, take the answer, which is 65.33333, square it, which is, that is the critical value divided by the standard error square, right? So once I have that, all I need to do is I say, okay, take that answer and multiply to 0.34. And then whatever the answer is, I just tell that answer to take that and multiply to 1 minus 0.34. And then again, this is what I have. So if you want to, you can do it that way in terms of typing a small step at a time and just tell your calculator to do it. If you don't, then if you want to type the whole thing in, then you have to put in the parenthesis to make sure that your calculator know what number to do, right? So if you want to type the whole thing in, this is what you need to type in, which is open parenthesis 0.34, open parenthesis 1 minus 0.34, and then open parenthesis 1.96 divided by 0.03, close the parenthesis, and then the square is right here, which is you tell your calculator that this parenthesis you have to square. So if you type this thing in, did I type in?
You forgot the
parentheses there.
Did I type in the wrong number?
after the 0.34, you forgot the close parentheses.
I see. Let me see. So to show you that if you type it in, make sure you have the parenthesis. So, no. So open parenthesis 0.34, close the parenthesis, open parenthesis 1 minus 0.34, close the parenthesis, open parenthesis 1.96 divided by 0.03, close this, and then square. Again, as you can see, hopefully to show you that if you type everything in, make sure you have all the parentheses correctly in order for you to see the same answer, which is again 957.83, right? So again, we have to round this number to be 958. But again, looking at this thing here, like I mentioned, this is what I do. That's why for me, I like to do it a small step at a time. so that I know that if I got it wrong, I know what step I got wrong. If you type the whole thing in and you depend on your calculator and you trust that you type everything in, then you just take whatever the output is. Sometimes the output is the wrong output. And again, I know the wrong output because my answer cannot be a negative, right? I'm looking for the total number. How can I have negative people, right? So looking at this thing here, how about I say that again, my answer is 957. As long as there's a decimal, I have to round up, which is 958. Question with this formula here and question of where I got my number from. And if you don't have question with this thing where they give you the proportion, if they give you the proportion, you have to use this formula. As you can see, B, the next question is they say, well, let's say if we don't have this proportion. We never did this survey. We never have this proportion. Estimate the sample size needed if no estimate of P is available, meaning we don't have this data in our hand. So if we don't have this data in our hand, this is the formula we're using, which is, again, we just assume that 50% of the people will say is again better and 50% doesn't. And again, 0.5 times 0.5, that's where the 0.25 come from. But you don't have to know where the 0.25 come from. Just know that if you don't have an estimator, if you don't have an estimate, then you have to use 0.25. This is a fixed number for say, okay? And again, all we do is we plug in the same number, which is 0.96 divided by 0.03, which is, again, this number is the same, which is 65.33 square, which is, again, 468 times 0.25, which is, this is what you have, which is 1067.1. And like I mentioned, because it's 0.1, we have to go up to the whole number, which is 1068, okay? So looking at this thing here, everybody see that if we have the estimate, if we have the own whatever estimate that we use, then we use in this formula. If we don't have an estimate, then we use this formula. There are two formulas that you have to use. Unlike 7.1, there's only one formula. And there's no, you have to type the number in your calculator so your calculator can calculate. There's no built-in formula here. Question with this thing here, A and B. Well, if you don't have question, that is the end of chapter 3.